very dyslexic. Typing is an issue. So, like any normal person, to try to show off where you could actually fetch data inside of an application, I decided to build an application just for that. So I built a very simple bare-bone listings page. It very literally lists a whole bunch of different boats for sale. So kind of from an old project that was going on in the past. Essentially, here we can actually get like a general idea of where the LCP is, but I'll get to it in a little more detail afterwards. What you can see is the non-optimized version at the top, where you can see the loading of the page where it loads a template. The template then gets an image, and as that's going on, it loads what's called the data. Things start to appear, it loads the images and all that. Throughout the optimizations, you can see the difference. It'll load about 40 to 50% faster, and it will start the load with the initial data when it gets to that. So, first part I'd like to talk about is what actually is LCP. And it's a little confusing, at least to me, because there's two different sides to it. There is what it's intended to be and what LCP actually is. So, if you try to find a metric that says this page has loaded, like the page is now useful, it's been loaded, it's going, like what is the moment in time where that happens? When the HTML file has loaded? Probably not, probably still kind of useless, probably blank too. After that, you have a page that delivers some content, first paint, first meaningful paint. Again, it does not mean the page has loaded. Largest Contentful Paint was kind of designed to be that moment when the application is like actually useful. It's got like three main characteristics of what it's intended to be. It is user-centric and it's about perceived speed. It is probably when the most important piece of content has loaded on the page. Probably, though, because that's not always the case, and I'll talk a little more about that later. And it is also supposed to reassure the user that like the page is actually useful and that you're not just clicking on a random thing that's completely useless. That's what it's supposed to be, but that's not what it actually is. What it actually is, it's an API that basically measures the largest piece of content on the page. Largest piece of content can be an image, can be an SVG, it's a video, it'll be the preview of the video, if it has a preview, if it doesn't have a preview, it's probably going to be a video. Or it can be just like actual text. Here is an example, or actually two examples, of Google loading its content. Now, in the first example, you can actually see that it starts by loading, it starts by marking the search as the largest piece of content, because that kind of makes sense, which is also like the most useful thing you need to know at that point. After that, you're going to get the largest piece of content being text. Technically speaking, that's probably what you're there for. And then the images load. Why is it very? I don't know why the example showed the founder. It's a little egocentric, but not that important. That example is from 2019. I know it was taken, it was published in 2019. Second example, I took about a week ago. And so, when I said the thing about proving that the page is useful, this is a very good example of it. Because if you look at the page, and it loads, first thing, yeah, okay, it's the right search, right? Second thing, his name isn't big. But is it more important to have that text, which is going to take you a moment to read it, or is it more important to have an image that says, yeah, that's what I'm looking for, and then you move on. And then you actually have a text, which probably is what you're there for. Cool. Now, it's not always logical, though. It's supposed to be the most meaningful content. But because it's an API and it's kind of flawed, it can just mark things that shouldn't be there. This example, you can see that in the application that I built, the mobile version will show the first text because that's pre-rendered and that appears pretty fast. then the loading image, kind of normal. And then when the actual image loads, that'll be the next most valuable piece of content. So there it kind of makes sense. On the desktop version though, there's a very large banner of text. And maybe that's good to reassure the user when the page starts to load, but the second that anything else loads, like that's not really useful. I'm not sure why that would be. But it is the largest piece of content. So technically speaking, the API thought that. From here on out, when I talk about largest contentful paint, I mean what it's intended to be. Is that piece of useful content on your website that reassures a user that the page is useful, the page is loading properly, everything's good, and basically you're arriving towards the end of the navigation, towards the end of the initial navigation. So, why should you care? If you have an application and you're thinking about whether or not it's worth optimizing, you can have many reasons why you care, and you probably care a lot more about building new features and about all these different things that you can do. I assume the majority of you know that performance is somewhat important for user experience, but how important is it really? I don't know about you guys, but when my pages take a little while to load, I get anxious. If you ask me to check out a website while we're talking, and it takes more than 2 seconds to load, I'll save it for later and probably check it. Sure, I'll check it. I won't check it. But it'll be on my history, so maybe it'll be there, right? Cool little examples. Let's start with Pinterest. This is 2015 to 2016. They decreased the perceived load time for their application, showing content faster, about 40%. And that increased the amount of traffic they got from Google by 50%, and increased the amount of people that they actually signed up by another 15%. That's, I don't know if that sounds massive to you, but it's actually pretty massive. In addition to that, this was put in place in 2016. They kind of re-engineered their architecture because of this finding. They actually built a fake pre-rendered page, pushed it, and then went back to re-engineer their application, and they figured out that they were actually going to get some massive financial benefits from it. Right? And they attribute their largest growth from 2016 to this massive performance gain. Cook. Cook is an online retailer. Do you buy frozen food? I think, or not? Super. It probably sells food, dining related things. They decrease the amount of time that it takes for the page to load. Perceived time again, like it's the LCP that I'm talking about. Important content is now visual, and that actually increased their conversions by 7%, so 7% more people who were arriving who were actually purchasing, and the amount of pages that any particular session, anytime somebody goes to the website, the amount of pages they actually go through increased by 10%. If you're trying to sell things online, having them browse your catalog is probably a good idea. All right. So there's another reason why I'm actually talking about this. The reason why I'm talking about this is because it turns out that it is actually one of the hardest things to optimize, or it's just one of the things that people optimize for the less, even though it's probably the most important one. According to the user experience Crux report, 52% of the pages that they've collected, and the data that they've collected, only 52 of them loaded under 2.5 seconds. If you work in any particular application, check it. You know, just go on a Lighthouse report and check how long it takes to load. You'll be impressed by some of those results. LCP, CLS and FID, so that's cumulative layout shift and first input delay are considerably better aspects. I'm not really going to get into that right now. So before I get into talking about how to optimize, like what moment should you actually look into pulling in data, what moment should you actually fetch data, I just kind of want to make this statement, which is a belief I don't know could be incorrect, but if you're trying to get data, you should try to get it as late as possible, but before you need it. So if you were going to get an image, you wait until the image is actually going to be necessary, but before you need to display it. So that's kind of the way you're going for it. Because if you try to load everything at the beginning, your application is going to be slow as hell, because it's just loading a lot of things and everything else starts to lag behind. Cool. Now, got this interesting methodology, right? This is kind of an overview of how you can measure like where you're at and where like the most painful part of your loading process is. It's got 4 different parts. The first one is first input delay, which would be referring to the amount of time the server actually takes to send the beginning of your request. If you've got a server-side application that is actually doing a lot of work in the back end, that might actually suffer. Then you have resource load delay. So that is anywhere between the moment that the document has loaded or started to parse and the moment that you're actually loading that piece of data. And the third part is the actual document loading. So if you have an image, text, data itself, whatever it is, how long it actually takes to load. And the fourth part is between the moment when you are actually done with loading the data and then when you're actually like rendering the data. The reason, like from here on out, I'm going to be talking a lot about the midpoint there. So the second section, the resource load delay. So the reason why that is because that's usually the largest part, and that's where applications suffer the most. This by the way, from Google I/O, public information. It's also like free for anyone to check out. Point being, the largest point is usually when the whatever is happening in between loading the page and actually getting the data. So that's usually a smart place to focus on. Okay. So the techniques that I'm going to be talking about, these 5 points in time where you can actually get data, are these. So the first part I'm going to talk about is loading it in the parent components instead of in nested components. From there, I'm going to try to explain how a boot resolver can be used, both to optimize it and also to reduce the amount of work that the browser has to do for no particular reason. Then I'm going to move the request itself back to the app initializer. From there, I'm going to push it back to the index.html and also preload the actual images inside of the app initializer. At the end, I'll also talk about size and format for images and how that can affect performance. All right. This is my starting point. This is the application that I showed you guys, and this is how a flame chart would look for it. Does look for it. I don't know how familiar you guys are with flame charts, so I'll try to do my best to walk through some of these parts. Essentially, the part that's marked as 1 is until the file actually starts to load. The HTML is actually started to be parsed and not just a request being made. Part 2, everything that happens until the actual file that is contributed to the largest contentful paint, like the actual object itself, is being loaded, right? 3, logically that. And in my application, we actually don't have a 4th. And that is because basically the largest contentful paint is being loaded at the very end. Not a very good thing though. 2 additional details there to note. This is a path with a lazy loaded module. I hope most applications have that now. And the data is basically you make an HTTP request, and in that HTTP request, you'll actually get the data that puts out the listings, and you move on from there. Cool. So, just for the picture.
Picture with flame charts always good.
Hey, don't worry, they'll get more complicated. If you didn't like it here, you're going to have a bad time. I'm sorry in advance. It's not really an option not to show flame charts if you're talking about performance. All right. Yeah, sorry, I can see your face. Okay. Anyway, so the first part that I would like to talk about is moving it up the component tree, right? So if you're going to fetch data, it's probably a good idea, if you're going to fetch data inside the components, it's probably a good idea to do it as early as possible. Basically, as you can see in the chart, what I would request is to actually get it in the container component or in the highest up container. So if you're using, for example, an async pipe, you would subscribe as early as possible. You would actually make the async part. The further down you do it, the later in time that you're actually going to make that request. Makes sense? In this case scenario, the little blue dots that you see are the passing the data with an input line. Pretty straightforward. And the last point is where the data is actually being rendered, so where the H is marked. If anyone has any questions about the chart, I'm happy to go a little more in detail. You can stop me for a second. If not, I'll keep going. So that's what I'm suggesting. This is the first and the least impactful one, and as we go down, you'll see that things start to make a lot more difference. What this is going to do in practice is that it will move the request a little bit earlier in time. If you do have a lot of components in your component tree, and there's a lot of things going on, it can make a difference. If not, still kind of a good practice to just get it earlier and mark it higher, at least in my opinion. Maybe wrong. As you can see, if we were to have it in the child component, the request would have been created where the second template is being marked, but since we're doing it in the parent component, it is going to be started there. You can also see the point where the request is actually made, that little tiny dot at the bottom. Okay. So, didn't have before and after for that, for like what the performance difference is, because in this application it's pretty minor. From here on out though, you'll start to be able to see a little bit more where the performance actually comes in. The next point in time, we can actually like push back the request, or where I would suggest pushing back the request, definitely more options, is a route resolver. So a route resolver is basically a moment in time or a function that you can run within the navigation that is going to be before the component gets initialized, but after it starts being initialized, somewhere in between that part. And it does a couple of additional things that I'm going to show you in a second. Essentially, if we don't use it, this is what happens. We're going to go ahead and bootstrap the component, and after we bootstrap the component, we're going to render that template. Inside the template, we're going to call the subscribe to the pipe, or just fetch the data. We get the data, we start loading it, and while we're loading it, we're going to render, in this case, the same loading component that was already pre-rendered for no particular reason, just that the component has already started. So there. Once it's the data has arrived, we're going to update the template with the new data, and it's going to do the additional work that we have in the back. If we use a route resolver to actually fetch the data, we can do two things. The first one is we actually get the data a little bit earlier in time. Any time earlier is usually good, at least it's data that you're 100% sure you're going to use. In this particular case, it is a synchronous call, which means that it's actually going to block the bootstrap process, and it's going to wait until the data has arrived to finish the bootstrap process, and it will only write the template once, which will also reduce the amount of work that the browser has to do. Depending on how big your component tree is how much work you're actually going to save on that. So, as you can see from another flame chart, you're going to love these, they're all over the place. Another flame chart is the work that was originally being done for the bootstrapping process is going to be divided up, and it's pushed to the back, and we start the resolver. And when we get the data, we finish the resolver, initialize the component, finish the activation of the component, bootstrap, then we go on, and that is when the actual template rendering happens. Yes, I reduced a little bit of work in the browser. I'm happy about it. If the component was very large and you had a lot of data, it would make a difference. Okay. Again, I moved it by just a little bit, but this is the first like technique or optimization where you're actually going to make a significant difference. If you know you're going to use this data, like there's no doubt on it, what you can do is you can pass it to the app initializer. You can actually fetch the data in the app initializer. What is the app initializer? It's basically the earliest moment in time in Angular where you can actually run functions, set up anything that you need to set up, initialize any database, anything of that sort. This is that moment. Back to a beautiful application. So, the little bar at the top over there is the main.js file finishing loading. And then we have the DOM content event. Again, that's when the whole bootstrap happens. At the end of that event, we're going to start the navigation. And that navigation is going to tell the browser what to load. It loads the component. And then we're back to the same point we were before, where we get to the route resolver, and we fetch the data, and we go on from there. I didn't show the full chart because I don't need that information right now. This is a very simple version of app initializer. There is something to note there. If I was going to do it this way, what I would like to do is store it somehow. I would actually have to store the data that I'm fetching inside any type of store, whatever is your preference. What this does is it actually starts the request way early, right? So, the request the main.js file is done, compile everything, start the bootstrap process, and as we're going for it, we're going to have a run initializers, and inside the run initializers is when we're actually getting the data. That's the fetch request that you see all the way at the top. And while I'm fetching the data, I'm also going to go ahead and download the module. Therefore, I'm doing that at the same time. And then you see where the route resolver is. That no longer has to wait, because instead of actually having to wait for the data to arrive, it's arrived before there, and I actually didn't have to do that pause there. One little second. Cool. So it's basically the same piece of data that I just showed you, but the full flame chart of downloading the initial navigation. You can see the HTML file loads. That is when it started to load. From there, we can see where the module is loaded, as well as where the data is being fetched. And then it fetches the image, and then is when the largest contentful paint actually happens. You see that we have the HTML loaded there, right? So that's when things can start to happen inside the HTML file itself. So why not preload the data inside of the HTML file itself? We can actually use a preload tag to preload the data directly as the first task. So, same thing I just showed you. Yeah, that's basically the same one. Okay. Yes. This is what a preload tag looks like. Preload tag can load a lot of different types of content. Stop laughing. Preload tag can load a whole bunch of different types of content. Here I'm using it to get fetch data. There is a little bit more to it, but I'm not going to get that far into it. If you are interested in how to actually use preload tags to fetch data directly, there is a couple of things that you have to adapt inside of Angular itself, or the HTTP client, to make that function. You can also load workers, scripts, images themselves, so we'll get into a little later. And if you want to load data, cross-origin is necessary. That's not an optional thing. Cool. So what that means is that if I use that in the index.html file, I am going to load the data way earlier. Like, data's loaded there. There's where it was supposed to load. That's a pretty large improvement, right? Now, that didn't change when the image loaded. The image is the largest contentful paint. So even though it did load earlier, it didn't really make a single difference. Everything else just kind of stayed the same. Which, in this particular case, is not a good thing, because I loaded things earlier than I needed them, and it didn't do anything. So why not actually preload the LCP image inside the app initializer? Now that I've got the data by the time that we get to the app initializer, right? I can actually preload the actual image inside of that app initializer. Here's the app initializer. Data has already been fetched. Module is being loaded over there, and you can see where the image loads. In the same way that I use the app initializer to prefetch the data, I can also use the app initializer to inject a preload link into the head of the document. Basically, it's you just have to manipulate the document and add a link. There. And what this does is it will load the data way earlier. It starts to load the actual picture as the component is actually loading, and so therefore it will reduce the amount of time from the moment that the template has already been built, the component has been bootstrapped and initialized to when the largest contentful paint happens. It still, though, does leave a little bit of time, as you can see, between those two moments. And what I want to do next is try to reduce that even more. However, that's basically the moments where I can actually pull in data within Angular. I could try something that I'll talk a little bit later about to try to create a script inside of the HTML file, but it wasn't necessary for this case. And as I said, as late as possible before it's needed. So that is, again, our beautiful chart that explains these 4 moments in time. And we can see that we have now gotten that improvement, right? First part is still the same. The resource delay, this is still not the improvement. This is just showing where it would be. See your face there. This is the resource load delay. The time where the image loads. The part that's marked in green with the word improvement is how much sooner, hard to see, is how much sooner I would actually be able to load the data and get the largest contentful paint. This is what I mean. We've now loaded everything faster, and it reduced the amount that the improvement showed. However, as I said, I'm still actually rendering the template before the data is physically visible and before the image is actually ready. So if I can move it back a little bit more, that would be nice. As I mentioned, I can actually preload it using a script inside the index.html, and I can actually make it so that the data, when it's done loading, it'll actually preload the links for that instead of waiting for the app initializer, and it would probably do the same thing. But instead of that, I'm going to talk about optimizing images. There's really a lot to optimize in images, so I'm really going to stick to the basics here. I also don't know how I'm doing on time, so okay.
That's perfect. Let's go.
So, basically, there's a couple things to consider. The first one is the format. Most people still use JPEG for some reason, or PNG and all that. WebP, on the other hand, will reduce the size of any image, or most images. It doesn't do very well with things sharp contrast. That's a little more of a detailed part of it. As long as it's glossy, it will reduce the file size by about 25 to 35%, 34%, not bad. And how is it on browser support? Well, I don't really care about Internet Explorer, but I think we're done with Internet Explorer, right? Woo! Yes! I'm about that. Cool, so that's probably the way to go. We have another option, IVIF, which is technically faster. How much faster? I think it's an additional 15% from what WebP would work. So whether or not you want to use it, I personally don't, but it would still save you a little bit of additional thing. And if you do want to use it though, and you want to make sure that the image still does load for the user, you can use a picture element. The picture element will basically allow you to give multiple different options for the browser when it's downloading the image based on different types of criteria. For example, you can give it the option of, if you can take wait, I don't know what the abbreviation for that is. Anyway, it'll take that. If it can't, it'll download the WebP. I don't know how common it is to use the picture tag, but it's actually quite useful. The second detail here is that the image is actually larger than it needs to be. If you look at applications just in general, this is like always the case. I don't know if I've ever audited a company that went, hey, our images are properly sized. There's always something, and as you're looking through, usually an application will be large enough that you'll go through it and there'll be at least one image that is just like outrageously large because the guy who gave it to you and you didn't really think about resizing it, and you don't see the size written on it, so like, doesn't make a difference. But yes, anytime you can make an image smaller, it will, logically speaking, reduce the amount of time it takes to load. In this example, we can see that the image that we're using is going to be rendered or displayed at 165 pixels times 150, so it's width and height. And the image is actually being pulled in, and its natural size and width is at 400 to 300. So that's a pretty big difference right there. Then again, maybe your application serves different size images. You could do some fancy JavaScript in the back, not necessarily at all. You can use the picture element to simply tell the picture, if the size of the screen is this size, load this image. If not, load the other one. And of course, both of that and the use case with different types of formats will work together. So, and you can do a lot more in that direction. Before we did the image optimization, this is what we got, right? That is, again, the resource load delay. Once we get to that, we have the amount of time that the picture takes to load. And before that is complete, we get when the component bootstraps and a little more, it's going to call it bootstraps. And after that, we get the image is actually loaded in the largest contentful paint event. If we optimize it, we can actually reduce that significantly, and we can actually get the picture to load before the component has finished bootstrapping, before the template moment happens, which means that we finally have an element render delay. I say that like it's a good thing because it kind of is. You want to get the image as late as possible before it's needed. That tiny little gap is my before it's needed. At least that's what I like to think of it. Cool. So just to give you an idea what the final results are. Same chart that I've been showing you throughout the thing. Same example. We've now loaded the data inside of the, we've now fetched the data from the index.html file. And when the app started to initialize, we started to load the images that were going to be the largest contentful paint. And once that was complete, we bootstrapped the component, and we have a little bit of time, which is really minimal, before the largest contentful paint and before the element has, the template has rendered. Cool. That is it. I don't know if you guys have any questions.